Welcome to my CompTIA Security Plus course video series. So in this third video, we will cover the domain 3 of the Security Plus exam course. I will guide you through the key objectives outlined by the CompTIA, ensuring that you understand what's required to pass the exam confidently. Be sure to like, subscribe and hit the bell icon so you don't miss future videos covering all the 5 domains of the exam. Now let's dive into the domain 3 and get you one step closer to becoming Security Plus certified. Welcome back to our CompTIA Security Plus course, and today we will study the domain 3, that is security architecture, and the first objective 3.1 is compare and contrast security implication of different architecture models. So let's get started. So first we will go through different architecture and infrastructure concepts. And the first we will get the concept of the cloud, the different cloud service models, the responsibility matrix between the cloud service provider, that is CSP, and the user. Then we will study the hybrid considerations of different cloud deployment models, and then the security consideration and implication of third-party vendors. But first, let's go through the cloud service models. And as you can see, we have these three popular cloud service models: infrastructure as a service, platform as a service, and software as a service. And the first one is infrastructure as a service. So IaaS, or infrastructure as a service, basically provides virtualized computing resources like servers, storage, and network. And its popular example are the Amazon Compute, that is EC2, and the Microsoft Azure VM. And the most important point is that in IaaS, or infrastructure as a service, the user is able to manage the operating system, the application, and the middleware, while the provider manages basically the underlying hardware infrastructure. So besides these middleware, of course, the user also manages the data and the user management as well. So this is important point, and we will also study it in the upcoming slides. As I flashed in the first slide, that about the shared responsibility model. So in this model, the user has the most flexibility in terms of managing the resources, such as the user can install its own operating system. The user can configure operating system as per their own requirements, and then application, middleware, and so on and so forth. And as we go to other cloud services model, these responsibility, or the resources that user can manage, it will decrease, and the CSP, or the cloud service provider, responsibility will increase. So in the next one is platform as a service, and this basically offers a platform to develop, test, and deploy application without managing the underlying infrastructure. For example, Google App Engine and Microsoft Azure App Service, and it includes tools, frameworks, and runtime environments. So here, as we see in this first point, that without managing the underlying infrastructure means that user no longer have to manage the operating system and the middleware. These are taken care of by the cloud service provider. The user only gets the software development environment, and then the user develop and test and deploy their application. So that is the main difference. As I said earlier, that the user responsibility, or user management responsibility, decreases as we go from infrastructure as a service to other models. And the next one is the SaaS, or software as a service, which delivers fully managed applications over the internet. Example include Gmail, Microsoft 365, and Salesforce. And the user has user access software via a browser, with the provider handling maintenance and updates. So here the user has the least responsibility. User do not have to manage anything. Even the application is being delivered and managed by the cloud service provider. User only needs a client or a browser to access this application. And the last one is the function as a service, which is basically this platform provides an environment where the user executes code in response to events without managing servers, often called serverless computing. Again, here user run their code without managing the underlying VMs or underlying infrastructure. Example include AWS Lambda and Azure Functions, and it basically focuses on specific tasks, paying only for execution time. What does this mean? That when the user executes code, then the VMs or the required resources are activated, and the user are only charged for that specific time when these servers or VMs or storage, etc., are activated during the runtime. When the code is not executed, the user is no longer charged for the resources such as compute or VMs. So, what is the shared responsibility model? So now we will again go through each service model and describe or explain the responsibilities of the customer, the cloud, and some shared responsibilities. So in the infrastructure as a service, the CSP or cloud service provider is responsible for basically the physical hardware such as the server, network switches, firewall, etc., the networking, the underlying networking, including router, switches, firewall, load balancer, the virtualization software such as the hypervisor, and of course the physical security of the data center. While the customer is responsible for the operating system, the application, the middleware, the data, user access or user management, as well as the configuration of these application, operating system, and the virtualized network as well. So what are the some shared responsibilities? The shared responsibility includes security of the cloud infrastructure, for example, network security and storage encryption. So here the security of the cloud infrastructure does not mean the physical security, which is the responsibility of the cloud service provider. Remember, the physical security of the data center or these infrastructure is always the responsibility of the CSP. Here we are talking about the security configuration of the network appliances such as the ACL or the firewall security policies configuration are enabling the encryption on the storage. Sometimes the encryption will be enabled by default by the CSP, and sometimes the user may be given the flexibility to use its own encryption or its own encryption configuration of the storage. So the next one is the platform as a service, and in this the CSP handles underlying infrastructure, but this time the operating system as well, the runtime for the application development and running, the middleware and the platform update. So now we can see that CSP has more responsibility in PaaS as compared to IaaS, and the customer focuses on application development, deployment, and securing the application and data. So here the customer only develop the application, then deploy it, and the security of the application and data. And what are the shared responsibility? The shared responsibility include the identity and access management, that is IAM, and data protection. So as you can see, the data protection is shared again between the CSP and the user. The next one is the SaaS or software as a service, where the CSP has the most responsibility and the customer has least. The CSP manages everything, including the application, platform, infrastructure, and everything else, such as the physical security, physical hardware, as well as the virtualization operating system, meaning the hypervisor, as well as the OSs of the VMs as well, while the customer basically manages the data, user access, and compliance with the regulation. And what are the shared responsibilities? These include the data security, user authentication, and access management. And the last one is the function as a service, where the CSP manages the serverless infrastructure, runtime environment, and scaling, while the customer only writes and secures the code and configures, triggers, and manages data access. And shared responsibility includes security of the application logic and API integration. So again, as we studies, this graphic shows the responsibilities, shared responsibility in different models between the customer and the CSP. So the blue one are the customer responsibility, and this color, you can say this is orange or brown, this is the CSP responsibility. So as we see in the infrastructure as a service, the user or customer has the most responsibility up to virtual networking, operating system, middleware, runtime application, etc. While the underlying physical hardware as well as the virtualization OS, such as the hypervisor, physical server, storage, and physical networking, as well as the physical security. Remember, physical security is always the responsibility of the CSP. In the past, the user is only again responsible for the people identity or user access, the data, and the application, while the rest, so as we can see that now the customer takes care of these things as well, as opposed to in infrastructure as a service. And in the SaaS, the user has only to manage the people identity and the data, while the rest, everything is taken care of by the CSP. And again, this is the summary of what we have studied so far in the shared responsibility model. So again, these are the same thing, but summarized in this table. You can pause the video and go through if you want. So we are talking about cloud services model now, different cloud deployment models, that how cloud is deployed differently in different models. And these models include the public cloud, the private cloud, the hybrid, community, as well as the multi-cloud model. So we will go through each of these one by one and explain that what does we mean by these different deployment models. So the first one is the public cloud. So as the name indicate, it is publicly available to everyone. So definition is that a cloud environment where resources like servers, storage, and application are owned and managed by a third-party cloud provider and shared among multiple tenants over the internet. So as this diagram shows, the public cloud is accessible over the internet all over the world by anyone, and these resources are basically shared among multiple tenants, which are basically in thousands. And these, the IBM, Amazon, VMware, and Google are some of the most popular public cloud providers. So key features include scalability, cost efficiency, and no need for hardware maintenance by the customer. So since these are very huge cloud provider, they have the capability of scalability, and they have cost efficiency because they have thousand upon customers. So their resources are cost efficient, and of course they are managed by these provider as well, and user do not need to maintain the physical hardware or the physical security of these cloud data centers. Use cases include hosting websites, application development, and backup solution. What does backup solution mean? If let's suppose you have an organization that have an on-premise data center, or you have traditional infrastructure, but you want that your backup be stored inside the cloud. So you can use one of these providers for storing your backup so that it is easily accessible from anywhere. Example include Amazon Web Services, AWS, Microsoft Azure, and Google Cloud Platform, that is GCP. So these three are the most popular public cloud provider. Consideration include that the user has limited control over infrastructure and potential security concern for sensitive data. Since your data is shared with multiple tenants and it is available inside the cloud, You have, of course, security concern for your sensitive data. But nonetheless, these cloud providers have very robust and very advanced security measures. Second deployment model is the private cloud. As the name indicates, it is private to an individual organization. So a cloud environment dedicated to a single organization, either hosted on premises or by a third party provider. Key features include greater control. So of course, it is owned by the organization. So organization has the 100% control over their cloud, customization, and enhanced security for sensitive workload. So if the organization have very sensitive data and they do not want to share it or store it inside the public cloud, they may deploy their own private cloud, and again they can then share their sensitive workload in their private cloud. Use cases include industries with strict regulatory requirement, for example, finance, healthcare, or business needing high security, as well as, let's suppose, we can include the military. If military is required a higher security requirement, so they can have their own private cloud. Example include VMware private cloud, Microsoft Azure Stack. So again, these provider can give you private cloud deployment, such as VMware has the private cloud and the Microsoft Azure Stack. Consideration include, of course, they have higher cost and maintenance responsibility compared to public cloud. So if you want to deploy your own cloud, again, you will need to deploy all the physical as well as virtual infrastructure. It means it will have the CapEx, mean the capital expenditure, as well as OpEx, that is operational expenditure. So these both will be high. These are two terms used for capital expenditure, that is the initial deployment expenditure, while the ongoing operational expenditure is known as OpEx. So these both will be high, while in the public cloud you have no capex, because of course the cloud is already deployed by the provider, and you have very little opex of the you can say pay as you use or pay as you go cost. And again, you have all the other responsibility of the security, including the physical security as well as the security of the virtual infrastructure as well. The second deployment model is the hybrid. As the name indicates, it is the combination of multiple clouds. So it is a cloud environment that combines basically the public and private clouds, allowing data and application to be shared between them. And the key features include flexibility to balance workloads, scalability of the public cloud, and security of the private cloud. So what does this mean? That let's suppose there is an organization that has both the requirement for scalability, that wants that when their requirements increases, they can have the resources as needed. And they have also some very sensitive workload that they want to use the private cloud for these sensitive workload. So when an organization uses these both, then this type of setup is known as hybrid cloud. Of course, the organization may have traditional infrastructure as well. So the combination of these two or these three is known as the hybrid cloud. Use cases include businesses needing to run sensitive operations privately inside the private cloud while leveraging the public cloud for scalability. Examples include Microsoft Azure Hybrid as well as AWS Outpost and Google Anthos. And the consideration include that this requires effective integration and management of both environments. So since the organization is using both these cloud, this integration between these two must be effective and seamless so that there are no technical hiccups. Another is the community cloud. As we see that it is owned by community, or you can say multiple organizations or multiple users. So a cloud environment shared by several organizations with common interests such as regulatory requirement or similar goals, often managed by a third-party provider or managed internally. Key features include collaborative, cost sharing, and tailored to specific community needs, for example, healthcare or government. So this is a cloud that is used by multiple organizations that have similar interests or similar requirements. Use cases include joint ventures, research organizations, or industries with shared compliance requirements. And the examples include government cloud services. So of course, when government has cloud service, it may be shared among multiple government organizations. Healthcare data sharing platform. So this healthcare data share platform may be used by multiple healthcare providers and hospitals. Considerations include cost are shared, but governance and security need careful coordination among community members. Another deployment model is the multi-cloud, which is the use of multiple cloud services from different providers to avoid vendor lock-in, enhance redundancy, and optimize performance. Vendor lock-in means that when a user organization is restricted or locked with a single provider, while the multi-cloud means that the user or the organization is getting services from multiple cloud providers such as, let's suppose, IBM, Azure, as well as, let's suppose, AWS. So key features include the flexibility, risk mitigation, and the ability to choose the best services for specific needs. So let's suppose there may be one service that is best provided by the Azure, or maybe it is most cost effectively provided by Azure. So the user organization may choose service number, let's suppose, one from Microsoft Azure, well, there may be another service that suits the organization from IBM, and the service number two then may be taken from the IBM by the organization. Risk mitigation is it means that, let's suppose, if you are using a single cloud provider and this cloud provider services goes down due to any reason, you can always switch these services to the second provider, since you are also using the second provider, and your risk of unavailability is mitigated. And these other redundancy as well as the performance optimization. Key features include, as we studied, the risk mitigation and ability to choose best services from each provider. Use cases include large enterprises or businesses with diverse needs for different workloads. For example, one provider for storage and another for compute. Example include using AWS for computing, Microsoft Azure for AI, and Google Cloud for analytics. And the consideration include, of course, if you are using multiple cloud provider, you have increased complexity in the management as well as integration across multiple platforms. Another cloud related term is the infrastructure as a code, or IAC, which is the practice of managing and provisioning cloud infrastructure such through code rather than through manual process. What does this mean? That, let's suppose, you want to create 4 VMs, and let's suppose some other configuration. Then instead of configuring these VMs through manually, you can write a code, a template that is already available, or you can write one custom template, and when you run this code, these VMs are automatically created. And of course, you have to write this code once or customize it once, and then you can always run it again and again as per your requirement. So it means you are creating the infrastructure through the code. That is why it is infrastructure as a code. Key features include automates infrastructure setup and management. It enables version control and consistency across environments. So if you have one template for infrastructure creation, you can use that template across multiple environment, and they will be consistent because you are using the same template, and there will be very less chance of human error. Increase efficiency and reduces human error. Tools for the infrastructure as a code include Terraform, AWS Cloud Formation, and Ansible. And the benefits include faster deployment and scaling, easier management of complex infrastructure, and improved collaboration between development and operations team. The next cloud related concept is the serverless. What is the serverless? It is basically a cloud computing model where the cloud provider manages the infrastructure and the user only focus on writing and deploying code. So the serverless give a meaning that it is without any VM or server. What does this mean? This means that user does not have to manage any server. For user, it is serverless. But of course, in the background, the servers are running and are managed by the CSP. Key features include that the user have no need to manage servers or infrastructure, automatically scales based on demand, and pay per use model that is charged only for actual compute time. Examples include AWS Lambda, Azure Function, and Google Cloud Functions. And benefits are it has simplified deployment and reduces operational overhead. It has faster development cycles and cost efficiency, and scalable and flexible for variable workloads. Another related term is the microservices, which is a design pattern where an application is built as a collection of small independent services that communicate over APIs, that is application programmable interfaces. Key features include each service is focused on a specific business function. Services are loosely coupled and can be developed, deployed, and scaled independently, and enables continuous delivery and DevOps practices. What does this mean? It means that instead of deploying or developing a huge applications, instead what microservices do that it develops individual microservices for a specific functionality, and then these communicate with each other through APIs. So this has the flexibility that you can independently develop and deploy these individual modules and gives the flexibility. Features include or benefits include improved scalability and fault isolation. Of course, if you have a fault, you don't need to disrupt the whole application. You will just work upon the individual module or the individual microservice that has default, enable faster development and deployment cycle, because you won't need development of the whole monolithic application. Rather than you will work on individual microservices module. Facilitate technology diversity, such as service can use different technology. You can use different technology for different services. Example include e-commerce platform and online payment systems. So now some concepts about the network infrastructure, and the from the security point of view, there is the requirement of physical isolation of the network infrastructure, which means that the practice of separating network resources physically to prevent unauthorized access, enhance security, and ensure data protection. Key features include it involves the use of separate hardware such as routers, switches, and servers for different network segments. It protects critical systems and data by ensuring they are not connected to the same physical network as less secure systems. And then another related term in the physical isolation is the air gap network. So, what is the air gap network? It is a specific type of physical isolation where a network is completely disconnected from other networks, including the internet. As we can see here, so this is a network of an organization, and this is wholly solely a private network. It is not connected to other network such as the internet or another organization network. When it is connected to an internet, of course it is connected to the whole world, and this is then no longer an air gap network. This is a non-air gap network. It provides the highest level of security typically used for sensitive or classified information. prevents external attacks by isolating the network from all external connections. So of course, since your network is not connected to external networks such as internet, there are no chance of accessing or launching attacks from external networks such as internet. Benefits include it enhances security by reducing exposure to cyber threats and limits the spread of malware or attacks within the network. So now the logical segmentation. In the previous two slides, we were talking about the physical segmentation or physical isolation. Now is the logical segmentation in the network infrastructure, which is the practice of dividing a network into smaller, isolated segments. Uses software-based methods to improve security and manageability. It means you have shared physical resources such as shared switch or shared firewall, but you can logically separate different workloads. Key features include achieved through the virtual LANs or VLANs, subnets, or access control lists, that is ACLs. And it does not require physical separation of hardware. You may have the same switch, but you can configure different VLANs inside the switch. You may have the same firewall or router, but you can configure ACLs among different workloads to block communication between them if required and enable better traffic control and monitoring. Benefits includes it enhances security by limiting access to sensitive resources. It improves performance by reducing unnecessary traffic and simplifies management of different user groups or applications. Example of logical separation includes separating guest and employee network using VLAN. So the VLAN separation or segmentation is very basic, and I must say that it is not a very secure method. Other methods include such as this one in this diagram. Let's suppose you have this physical firewall, and then you can separate multiple different workloads such as the HR, the marketing, and the sales workloads using ACLs or security policies. So these may be not physical firewall. These are basically or maybe virtual ACLs, or you can say virtual firewalls, so that you can configure policies between these workload. And if you want that the HR department should not talk to the marketing, the sales person, you can block communication between them. So it is then more secure than simply using VLANs. Another network infrastructure related concept is the software defined networking or SDN. So it is a networking approach that separates the control plane, that is decision making, from the data plane, that is traffic forwarding, to enable centralized network management. So traditionally, inside a network switch or a network router, both the control plane and the data plane, they were available inside the same switch or same network device. In SDN, we physically separate the control plane, that is the decision making plane, and the data plane, that is the forwarding plane, from each other. So here, as you can see, the control plane is physically separated from the infrastructure or the data plane. The infrastructure plane is also known as is basically the data plane. So again, these communicate through APIs, but they are physically separated. And it is called the decision making because all the decision, let's suppose the routing decision, the policy decision, are taken here, and then these are pushed in the infrastructure or the forwarding plane. Key features include that it has centralized control where software-based control. So here we have a controller, and all the control decision or the control of the infrastructure or data plane is taken by this controller. Dynamic programmable network configuration. So it is dynamic and configure whole infrastructure. Let's suppose here we may have 100 upon 1000 of switches. So we can configure their configuration from here and then push it downward instead of individually configuring each switch or router. Use APIs to communicate between applications and the network. As I already studied, that there are APIs between these layers that they communicate with. Benefits include simplified network management and provisioning, enhance scalability and flexibility for modern workload, and facilitate automation and reduces manual errors. Use cases include the SDN are used inside data centers, specifically software defined data center or SDDC. This is a concept known as the software defined data center where SDN is used, cloud environment. So again, the SDN is used in clouds and dynamic traffic routing. Example include OpenFlow, Cisco ACI, and the VMware NSX. So in the infrastructure concept, we studied cloud, and the opposite of the cloud infrastructure is the on-premise infrastructure. And this is a setup where all network, hardware, software, and resources are hosted and managed locally within an organization's premises. Traditionally, this was the way. And the key feature include that user or customer has the full control over infrastructure and data, requires in-house IT expertise for management, and higher upfront cost for hardware as well as the software. Benefits include enhanced security and compliance for sensitive data, customizable to specific business needs, and no dependency on external cloud providers. Considerations include limited scalability compared to cloud solutions and higher operational and maintenance costs. And again, this is another infrastructure concept, that is the centralized and decentralized infrastructure. So you can pause the video and study this self-explanatory, that what is the benefit of the centralized as compared to decentralized. Another infrastructure concept is the containerization or the containers. So what the definition is, that it is a lightweight method of packaging applications and their dependencies into isolated units called containers, ensuring consistency across different environments. Key features include uses OS level virtualization for resource isolation. Containers are portable and run consistently on any system with a container runtime, which is known as, for example, Docker, efficient and lightweight compared to virtual machines. So we had traditionally physical servers or physical infrastructure, then we went to VMs, which were efficient than the physical server, and after VM we can say that these are even more efficient and lighter than VM, which are the container. Because inside the VM we have, each VM has its own OS, while here we can see that it is the virtualization at the operating system level. What does this mean? That you may have multiple containers inside a single OS. And benefits include that it simplifies application development, deployment, and scaling. It enhances resource utilization and reduces overhead, and enables microservices architecture by isolating services. So tools include the Docker, Kubernetes, and Podman, and use cases include cloud native applications, CI/CD pipeline, and multi-cloud. CI/CD is continuous integration and continuous deployment or continuous delivery. Another infrastructure concept is the virtualization, which is the process of creating virtual versions of physical resources such as servers, storage, or network to improve efficiency and flexibility. So what does this mean? That traditionally we had the physical, let's suppose, server, and we will install an operating system on this server. But in virtualization, we install a hypervisor, or you can say this is a virtualization OS on this physical server. And then on this one server, we can deploy multiple VMs, with each VM acting as a isolated or separate server having its own resources such as storage, networking, as well as its operating system. Key features include that it uses a hypervisor to run multiple virtual machines on a single physical machine. Each VM operates independently with its own operating system and application and supports resource sharing and optimization. Benefits include that it increases hardware utilization and reduces cost. It simplifies resource management and disaster recovery and enhances scalability and faster provisioning of resources. So types include the server virtualization, storage virtualization, and network virtualization. And tools are popular virtualization tool virtualization software are VMware, ESXi, Microsoft Hyper-V, and Oracle VirtualBox. Use cases these are used inside data center, testing environments, and cloud platform. Testing environment include that, let's suppose you want to test a malware, so you can configure VMs where you install OS and study the behavior of malware or other application without damaging your main host operating system. Another infrastructure concept is the IoT or Internet of Things, which is a network of interconnected physical devices that collect, share, and act on data through the Internet. Key features include devices equipped with sensors, software, and connectivity capabilities. It enables real time data collection, analysis, and automation, and operates across various domains like smart homes, healthcare, and industry. Benefits include that it enhances efficiency and automation in daily tasks. It provides actionable insights through data analytics, and it supports remote monitoring and management. Examples include smart thermostats such as the Nest wearable fitness tracker Fitbit, and connected car and industrial IoT sensors. Challenges include security concerns, data privacy issues, and scalability. Another infrastructure concept is the Industrial Control System ICS or SCADA. So ICS or Industrial Control System refer to systems used to monitor and control industrial processes, while SCADA, that is supervisory control and data acquisition, is a subset of ICS focused on supervisory level monitoring and data collection. Key features include the ICS features include that it encompasses a range of control systems like DCS, that is distributed control system, and PLC, that is programmable logic controllers, while SCADA enables centralized monitoring and control of remote equipment via sensors and communication networks used in critical industries such as energy, water, manufacturing, and transportation. And the benefits include that it enhances operational efficiency and reliability, it provides real time monitoring and automated control, and reduces human intervention and errors in complex systems. Challenges include it is vulnerable to cyber attacks due to increased connectivity, and it requires robust security and regular updates. Examples include power grid control, water treatment systems, and oil pipeline monitoring. Real-time operating system, that is RTOS, it is a specialized operating system designed to process data and execute tasks within strict timing constraints. Key features include that it prioritizes deterministic behavior and timely task execution. It includes real-time scheduling algorithms to meet deadlines and optimized for embedded systems and IoT devices. Benefits include that it ensures high reliability and predictability, and it is ideal for time sensitive applications like automotive systems, robotics, and medical devices. And it supports multitasking with minimal latency. Examples include FreeRTOS, VxWorks, and QNX. Embedded system. So it is a specialized computing system designed to perform dedicated functions within larger mechanical or electrical systems. And key features include that it typically consists of hardware and software tailored for specific tasks, often have real-time constraints and limited resources such as CPU and memory, and not intended for general purpose use. Benefits include that it is efficient and reliable for specific functions such as controlling machinery and processing sensor data. It requires low power, or it has low power consumption and compact design, and often integrated into consumer electronics, vehicles, or industrial machines. Examples include microcontrollers in appliances, automotive control systems, wearable devices, and medical equipment. So another infrastructure concept is the high availability, which is a design approach that ensures a system or service remains operational and accessible with minimal downtime. So as the name indicates, it is highly available all the time, and it has minimum downtime, and key features include that it involves redundancy. So of course, if you want minimum downtime, you need to have redundant resources, such as if the user require one server, you have multiple servers, so that if one fails, you have redundant server available. Aims for 99.9% or higher uptime, for example 3 nines availability, and typically implemented with clustered server or distributed system. So cluster servers mean that you have multiple servers clustered together that work together, and if one server fails, the user services are uninterrupted and seamlessly shifted to other servers. Benefits include that it minimizes service disruption and ensures continuous access. It provides reliability for mission critical application and enhances user experience and business continuity. Examples include cloud services, data centers, and financial transaction systems. And another related term is the availability, which ensures that services and systems are operational and accessible when needed, often measured by uptime percentages. So uptime is basically an institute, and for example, 999 or 99.9% availability. Resilience. So it is the ability of a system to recover quickly from failures and continue operating, ensuring minimal disruption to services. Cost. So we are talking about some consideration of the infrastructure. It is the financial implication of maintaining infrastructure, considering both initial investment and ongoing operational expenses, including the hardware, software, and human resources. So for the cost for the initial investment, we have the term that is used in the industry, which is a capex, which is the capital expenditure, and the OPEX, which is the operational expenditure. Capital expenditure is the initial investment, and the operational expenditure is the ongoing operational expenses. Responsiveness. So it is the speed and efficiency with which a system reacts to requests or changes in condition, critical for user satisfaction and system performance. Scalability. It is the capability to handle increased loads or demands by expanding resources, for example, adding more servers or bandwidth without significant performance degradation. Ease of deployment is the simplicity with which systems, services, or applications can be set up and integrated into existing infrastructure, impacting time to market and operational efficiency. Risk transference is the shifting the financial or operational risk of certain effects such as data loss, hardware failure to third parties such as through cloud services or insurance. So it is this term is used in risk management. You can mitigate the risk through transferring by buying the, let's suppose, insurance. Ease of recovery is the ability to quickly restore services or system after a failure, often involving backup strategies, disaster recovery plans, or redundant system. Patch availability is the timely availability of software updates or patches to fix vulnerabilities or improve functionality, ensuring system security and reliability. Objective 3.2, applying security principle to secure enterprise infrastructure. Now we'll study some infrastructure consideration, and the first one is device placement. So what does we mean by the device placement? It refers to the strategic positioning of network devices, for example, firewall, routers, servers, to optimize security and minimize exposure. Proper placement can isolate critical assets and prevent unauthorized access. So as we can see in this diagram, for example, if we want that these devices, the different group of devices, should not communicate with each other, we can place firewalls between them and block any communication between them. But if, let's suppose, our purpose was to only block external, let's suppose, access to these devices, but these devices can communicate with each other, then we only would need to place a firewall at the perimeter of the network, and we won't need these placement of firewalls between these different sections. So this placement is very important for the security as well as the other implications such as the performance and as well as the availability, etc. Another term is the security zone. So it is logical or physical segment of a network designed to separate system based on security requirements. Common zone include DMZ such as demilitarized zone, internal or external networks, each with different access policy. So again, you can divide different network segments based on their security requirements, and you can call them security zones. So one of the popular security zone is, of course, the DMZ, and it is basically the security zone inside an organization which is accessible from external network or which is accessible outside the organization, where you typically place your web server or let's suppose email server that are need to be accessed from the outside your organization, while you may have other critical secure systems such as your database, which must be placed inside a higher security zone, which you can call a private security zone or internal security zone. So this is the concept, and based on this concept you can have multiple security zone inside your organization based on the requirement of different devices and users. Another concept is the attack surface. So it is, we have already studied this, I think, in domain 2, and it is the total points where an attacker can attempt to exploit vulnerabilities in a system or a network. Reducing the attack surface involves minimizing the number of accessible services and interfaces. So, as the name indicates, it is basically the total number of paths or ways where an attacker can exploit your systems. So, how to reduce? The less the attack surface, the more secure is the system. So, you always need to reduce the attack surface, and it is done through removing or disabling unnecessary services, uninstalling unnecessary application, disabling the unnecessary open ports, and so on and so forth. Connectivity, it refers to the pathways through which devices and network communicate. Secure connectivity involves using encrypted channel through VPN and SSH/TLS and monitoring traffic to prevent unauthorized access. Another term is the failure modes. So it is basically the behavior of system or devices when they fail, impacting the security and reliability infrastructure. So when devices fail, they can have two options, either fail open or fail close. So the fail open, one in this scenario, in a fail open scenario, a system remains accessible or operational even if it fails, often for the sake of availability. However, it can create security risk if critical security measures are bypassed during failure. And another is the fail closed. So in a fail closed scenario, system automatically block access or cease operations in the event of failure to ensure that no unauthorized access occurs. While the fail closed is more secure, it may cause service disruption during failure. So it is always a trade-off. If you want fail open, your services will be available, but you may have security implication or security breach. While in fail closed, your system will be more secure, but you may have availability issue. Another term are the device attributes, that is the active and passive devices. So active devices are basically those that actively participate in processing, controlling, or managing traffic and communications. They make decisions based on inputs, for example, firewalls, routers, and switches, and they require power and can block, filter, or modify data as needed to maintain security. While passive devices, these are the devices that only observe and monitor traffic without altering it. They collect data or provide information for analysis, for example, network taps, intrusion detection systems. And they do not require power for operation and cannot interfere with the network traffic. Now, some network appliances, the first one is the jump server. So it is a secure intermediary system used to access other system in a restricted or isolated network. It acts as a hopping point for administrators to manage servers or system in a sensitive environment, minimizing direct access to production system. So as the diagram indicates, let's suppose this is a administrator or a developer that wants to access these production system. So we have this jump server. This is basically the jump server. In between, the admin first accesses this. He logins onto this server. This is a hardened and secured system, and from here, the admin can access this system. So the admin or developer is not allowed to directly access this system, and this jump server acts as a, you can say, a proxy or a hopping server to secure this system for any direct external exposure. Proxy server is again a server that acts as an intermediary between the clients and the internet, providing control over network traffic. It can enhance security by filtering requests, hiding client IP addresses, and caching data for faster access. So it has the same concept as the jump server. When the clients, let's suppose, want to access the internet, there is an intermediary, that is the proxy server, and its purpose is the security. For example, let's suppose you want your employees to prevent them from accessing certain websites, such as, let's suppose, social media websites. So this filtering can be done here. This also provides the client IP can also be hired. This proxy server can have a public IP, and it can apply netting, that is network address translation. So this internal external network, only this IP is visible. And it can also provide the cache purpose. So let's suppose the user are accessing, let's suppose, a company website or some data more often. So this website or this data can be cached here, and when the user accesses it, it is readily available instead of going to the internet each time. The data is cached over here. So that is the concept of the proxy server. Another network appliance or appliances are the network intrusion detection system and prevention system. So the IPS intrusion prevention system is a network security appliance that monitors as well as analyzes traffic to detect and prevent potential threats or attack in real time. It can block malicious traffic based on the predefined rules. So this is the IPS, or intrusion prevention system. It basically sits between your corporate LAN or your private network and the outside network such as the internet. And this placement is important. You can say that this sits in line, and each and every traffic passes through it. And if some malicious activity or malicious traffic is detected, it can block it, as opposed to the IDS, which simply detects. It does not sit in line. It does only receive the traffic goes directly over here. Only a copy of this traffic is sent to the IDS, as opposed to the IPS, where traffic directly passes to the IPS. So a system designed to detect and alert on potential security breaches or attacks. Unlike IPS, it does not block traffic but instead notifies administrator of suspicious activities. So some other network appliances, another one is load balancer, a very important one. It is a device or software that distributes incoming network traffic across multiple servers to ensure even load distribution, improve performance, and ensure high availability of services. It helps prevent overloading any single server and can be used for redundancy. So this is how it works. So you have a load balancer that sits in front of your servers. You have multiple, let's suppose, servers. Let's suppose these are web servers. And when your clients accesses these servers, the load balancing basically divides the traffic between them so that each server gets equal traffic, so the load is evenly distributed. It also provides high availability. What does this mean? That if, let's suppose, this server fails, the traffic is then distributed between these three servers and it is no longer sent to this server, and the user does not feel any service disruption or downtime. Another network appliance are the sensors, which are devices or software tools used to monitor network traffic, detect anomalies, and collect data for security analysis. Sensors are often used in conjunction with IDS and IPS to capture and analyze network activities for signs of malicious behavior or security threats. So what does this mean? That you can have sensor inside, let's suppose, these servers, and these sensors can monitor and send the data to, let's suppose, you have an IDS over here. So this is how the sensors work. You can also call them agents. Another concept is the port security, and the standard for port security is 802.1x. So it is a network access control protocol, also known as NAC, network access control. It authenticates devices attempting to connect to the network, such as this one. Let's suppose these are the devices and they want to connect to the internet. So they first go through this uh, network access control system, where you have the switch that is basically connecting these devices to the network. And once these devices want to connect to the network or the internet, the switch authenticates these devices from the authentication server. Let's suppose it is a radius. And this authentication can be done on through multiple methods, such as, let's suppose, these devices may have certificates, and these certificates are verified over here, or they can simply enter username and passwords, and these username and passwords are verified over here, and then they are given the access. So it authenticate devices attempted to connect to net, commonly used in Ethernet and wireless networks, involve three components. So the supplicant, so these devices that want to connect to the network are the clients, they are known as the supplicant. The authenticator, which is basically the switch that gives these devices access to the internet, and the authentication server that authenticate the devices, such as the radius. So a protocol is used in this whole 802.1x, and that is extensible authentication protocol. It is authentication framework supporting multiple methods. It works with 802.1x for Network Access Control or NAC. It supports methods like passwords, digital certificates, and biometrics. Now, some firewall types. So, we have multiple firewall types. One of them is Web Application Firewall, which is, as the name indicates, specifically designed to secure the web traffic. It protects web application by filtering and monitoring the HTTP and HTTPS traffic. It prevents attacks like SQL injection, cross-site scripting, and other web-based threats, and it operates at application layers since the HTTP or HTTPS is layer 7 protocol. Another firewall type is the UTM or Unified Threat Management. So this is a depiction of the WEF. It is basically sits in front of the web. Let's suppose you can say web server or web application, and any request goes through it. And if any malicious or unauthorized access is attempted, it is blocked. So UTM combines multiple security features into one appliance, includes antivirus, anti-spam, VPN, firewall capabilities. So you can say this is an all-in-one appliance, and it simplifies security management for small to medium-sized system. As this diagram indicates, it has firewall capabilities, VPN, this antivirus gateway, the routing capability, web security, and IPS, as well as email and anti-spam filtering. Another firewall type is the NGFW or next generation firewall, which is advanced firewall with added features like deep packet inspection and application awareness. It offers protection against sophisticated attacks such as malware and advanced persistent threats such as APTs. And it includes intrusion prevention and encrypted traffic inspection. And another term for the firewall is that layer 4 or layer 7 firewall. So layer 4 is basically the transport layer. It operates at the layer 4 firewall operates at layer 4 to filter traffic based on IP, TCP, UDP ports. So these are TCP, UDP are layer 4 protocol, while IP is of course layer 3 protocol. So this firewall basically works up to layer 4. Layer 7 firewall is more advanced because it operates at the application layer to inspect and control application traffic, and it provides more granular control over applications like HTTP, FTP, and DNS. So all these three are basically layer 7 protocols. Another secure communication access concept is the VPN, which is the virtual private network, and it encrypts internet traffic to secure data transmission over public network. It provides secure remote access to private networks and hiding IP addresses and ensure privacy. And remote access, it basically allows users to connect securely to a network from a remote location, and commonly implemented uses VPN, secure tunnels, or direct connection. Another term is the tunneling. This is also used in the network. It is a method for securely transmitting data over a public network by encapsulating it within another protocol, and it ensures privacy and integrity of data. Transport layer security, it provides encryption for data in transit, typically used in HTTPS or in web browser using HTTPS. It protects data from interception and tampering during transmission. And the IPsec, that is Internet Protocol Security, so it is also the type of VPN. So secures IP communication by encrypting and authenticating data at the IP layer, and it is commonly used in VPNs to establish secure connection between devices or networks. So this is the IPsec. It has basically two modes: the transport mode, which is basically between different clients, while the tunnel mode, it is between different gateways such as Here gateway means that you have firewall over here and a firewall over here. So a VPN is made between those two firewall, and all the devices behind these two firewall are secured. When they want to communicate with each other, the traffic goes through this VPN tunnel and it is encrypted. Software defined network, I think we already studied it, but its considerations is that it is a virtualized WAN that, no, it is SD-WAN. So we studied SDN, not SD-WAN. It is software defined wide area network. So it is a virtualized WAN that simplifies network management by using software to control traffic routing. It enhances security, improves performance, and optimizes the use of multiple network connections such as MPLS and broadband and LTE. So here I have included the diagram of this is basically SDN. This is not SD-WAN. So SD-WAN is typically a technology that manages the WAN connection more efficiently. For example, let's suppose an organization has multiple WAN connections such as MPLS, LTE, and let's suppose another one that is broadband. So what does the SD-WAN one? That first it distribute the traffic between these different networks. It does the, you can say, the load balancing, and it can also do the high availability, that if one connection is down, the traffic is routed to the next available connection or ISPs. Risk assessment, another, so we have now the topic of the selection of effective security controls, and the first terminology is the risk assessment, which is to identify and which identifies and evaluates potential risk to the organization, and it prioritizes threats based on their likelihood and impact. So you first identify the threats and then prioritize it based on their likelihood, that how likely it is this threat to occur and what is the impact. Regulatory compliance, so it ensure controls align with the industry standards and legal requirements, that is GDPR and HIPAA, and it helps avoid penalties and legal issues. Layered defense, that is also known as defense in depth, which is to use multiple layers of security controls to protect against various threats. Example include using firewalls, IDS, IPS, and endpoint protection all in conjunction. So another consideration is the cost versus benefit analysis, which evaluate the cost of implementing control against the potential losses they prevent, and the focus on high impact and cost effective solution. Scalability and flexibility, choose controls that can grow with organizations needs and ensure they adapt to new technologies and threats. Ease of implementation, consider how quickly and easily a control can be deployed, and balance complexity with effectiveness. Usability and user experience, so ensure controls do not hinder productivity or frustrate users, and implement user friendly measures like single sign on. So what is this is a user friendly? So if you have multiple applications, let's suppose app 1, app 2, and let's suppose up to 10, you have 10 applications. So if you the user need to log into each application, it means they need to remember 10 password and username. Instead, you can do is implement an SSO where user logins only once through SSO and then have the access to all the application. Effectiveness against threats, so select controls proven to mitigate specific risk, for example phishing filters for email security, and use threat intelligence to guide decisions. Monitoring and maintenance, ensure controls include mechanisms for continuous monitoring and updates, and regularly review and test controls for effectiveness. Objective 3.3 of the Domain 3: compare and contrast concepts and strategy to protect data. So now we'll talk about different data types, data classification, and how to protect data. So let's get started. So first of all, let's go through some of the data types that we use in our systems. The first one is the regulated data, and it is the data governed by laws or regulation to ensure privacy and security. For example, personally identifiable information, that is PII, like names, social security numbers. And this PII is basically governed by one of the most popular law, that is GDPR. And GDPR is basically applicable on the EU citizen or any company organization that deals with the EU citizen, and it basically deals with the privacy and protection of personal identifiable information of EU citizen. Similarly, HIPAA deals with the patient health record, and it is basically a US based law that governs the protected or sensitive data of patient. Another data type is the trade secret, which is confidential business information that provides a competitive edge to an organization. Examples include the Coca-Cola secret formula. So it is a trade secret for Coca-Cola, and they will make sure to protect this formula at any cost. And the proprietary algorithms in software development. So the source code or the algorithm used in software, for example, let's suppose we can say that the Microsoft Office or Microsoft Windows, so they are proprietary, and these also comes inside the trade secret. Another related data type is the intellectual property or IP, which is legally protected creations of mind that prevent unauthorized use. So it is the creations of mind, or you can say that the ingenuity of mind that has been created inside an organization, and it is protected against unauthorized use or exposure. Example include patents for a new smartphone design and copyrighted books, songs, and software. Another data type is the legal information, which is the documentation and records related to legal and regulatory matters. And examples include the employment contracts that the employees made with the organization that employs them. And the NDAs, again, NDAs is basically made it is a contract between the employees and the organization, which makes sure that the employee does not disclose the sensitive information outside the organization. Financial information, which is data associated with the financial transaction, budgets, or accounts. An example includes the bank account statements. So these may be of the individual customers or of the organization, and corporate budget reports and investment portfolios. And human and non-human readable data. So some data may be readable by the humans, such as this English language, while some may be not human readable, and they are basically machine readable. So human readable data is basically formatted for easy interpretation by people. For example, plain text documents such as this slide, the spreadsheets such as the Excel sheets, and emails. Non-human readable data includes, and this data is basically designed for machine processing or for storage. Example include the binary code and the encrypted files. So now data classification, and data can be classified based on its sensitivity levels, and these include the sensitive data, which includes the data that requires protection from unauthorized access but may not be legally regulated. Example include the internal company memos, employees ID numbers, and unpublished business strategies. Another is, so we are going from lower sensitivity to a higher sensitivity. So confidential is more sensitive than the sensitive. It is a highly sensitive data that if disclosed could harm an organization or individual. Example include the trade secrets, the financial reports, the customer lists, and the legal documents. We studied these data types in the previous slides. So these all comes in the confidential classification. And the next one is, this one is least sensitive, and it is the data that is openly or publicly available and does not require any protection. These are basically published by the organization for the public consumption. Example include the press releases, marketing brochures, and publicly posted product prices. Another type is the restricted data type, which is the data with the highest level of security that must only be accessed by the authorized personnel. Example include government classified documents, encryption keys, and top secret research. Another one is the private, which is the personal data associated with individuals that must be protected to ensure privacy. Private, as we earlier talked about the PII, the personally identifiable information. So this is basically the private data of the users or of individuals. Example include the social security number, the personal contact information, and health records. And the last one is the critical, which is data essential to an organization's operation where loss or compromise would cause severe harm. Example include database of patient records in a hospital, payment transaction data, and emergency response systems. So now some general data considerations. And first one is the data state. So we have basically three basic data state, that is data at rest, data in motion or data in transit, and data in use. So first one is the data at rest, which is the data stored on devices or server not actively being transmitted or processed. So this is basically the data in storage form. When you, let's suppose, store some data inside your hard drive or inside the cloud storage, this data is basically at rest. And example include files on a hard drive, database on cloud storage, etc. Consideration for data at rest include that for protection, encryption such as AES 256 should be used to secure the stored data. For example, if you have hard drive on your laptop or PC, you can use the BitLocker to encrypt your data. Implement strong access controls and audit logs to track unauthorized access. Another data state is the data in transit, or also known as data in motion. This is the data moving across networks or between devices such as this one. If you are, let's suppose, transferring data from one device, let's suppose laptop, to this smartphone or vice versa, then this data is basically in transit. It may be a wireless network, it may be a wired network, but this is the data in transit or in motion. Example include emails being sent, file uploaded to a server. Consideration include that, again, for protection, use encryption protocols like TLS or IPsec. So remember the TLS, IPsec, HTTPS, these are all protection for data in motion or data in transit. Verify endpoint authenticity to avoid man-in-the-middle attacks. So you not only require the encryption of data in motion, you also need to make sure that the end devices are authentic. If, let's suppose, we have Bob over here and Alice over here, it must be make sure that data sent to Alice is actually sent by the Bob. And we already studied in our initial domains that to make sure the authenticity and data integrity, we have the digital signature. So for confidentiality or for data protection, we need the encryption, while for the authenticity, of the origin as well as for the data integrity, we require digital signature. And the next data state is data in use, which is the data actively being processed or accessed by application or users. For example, you have a Word document open and you are actively writing something inside the Word document, then this type of data is actually data in use. Your data is Word file is actually being used, you are editing it, and during use the data is actually inside the memory, or you can say in RAM, because this is the temporary storage that store data while it is being used. For permanent storage or for data at rest, we use the HDDs, while for temporary during processing, RAM is used. Example include analyzing a spreadsheet or running queries on a database. Considerations employ memory encryption techniques such as Intel SGX or AMD SEV. So remember that it is easy to protect data while it is at rest inside the storage, but for data protection during its live usage, such as inside the RAM, the technique is more difficult, and we have special type of encryption techniques and special types of memory storage processing storage spaces for these, such as Intel SGX and AMD SEV. Minimize the exposure of sensitive data during processing using secure environments. We already studied that for protection of data during use, you can also use the, I think, homomorphic encryption. So it is the type of encryption which when the process or the application uses the data, it is used in encrypted form. So usually when you want to use data, the data should first be decrypted, and then the application or device can use it. By using the homomorphic encryption, the data can be used in encrypted form, and so it is secure. So this is also another technique that can be used for data in use. Now, what is data sovereignty? So it is the legal and regulatory requirements for storing and processing data within specific geographic boundaries. For example, GDPR mandates storing European Union citizens' data within the EU or compliant jurisdictions. For example, this is GDPR requirement that the EU citizen data must be stored inside EU boundaries. If an organization, let's suppose, is based in US or in another continent such as Australia, and it collects the EU citizen data, the data must be stored within EU boundary. Consideration include understand and comply with local laws and regulation. Choose cloud providers with data centers in regions meeting compliance needs. So for example, if you are using AWS, you should select the AWS region that is available inside EU for processing the or storing the EU citizens data. Geolocation, another consideration, which is the geographic location of where data is stored or processed. As we studied in the previous slide, this is also important from the context of different laws and regulation that governs the data. For example, cloud providers offering regional data centers such as AWS hosted data in US East or EU Central. So for example, if you are dealing with EU citizen data, you must select this region so that you are compliant with the EU law, that is GDPR. GDPR, by the way, stands for General Data Protection Regulation. Consideration include assess latency and performance implications based on the data's location, and consider geopolitical risk and the potential impact on data availability. Another data consideration is the geographic restriction, which is enforce data access or storage limits to specific region to comply with regulation. Again, as we studied, like the GDPR. Example include configuring a cloud service to restrict data storage to EU servers. Encryption, convert data into an unreadable format. So encryption is another data, is a method to secure data. So now we are talking about different methods to secure data. First one is that you can restrict data to a specific region. Second is the encryption, which converts data into an unreadable format without the decryption key to protect its confidentiality. An example includes using AES 256 to secure files in transit and at rest or at storage. Another data secure method is the hashing, hashing is basically primarily used for data integrity. So that data is protection against unauthorized alteration or corruption. Transform data into a fixed length hash that is irreversible, ensuring data integrity. Example includes storing passwords as hashed value with SHA-256. Masking, another data secure concept which hides sensitive data by substituting it with fictional or scrambled characters. For example, showing only the last four digits of a credit card number. So this is basically the masking technique. Tokenization, another method to secure sensitive data. It replaces the sensitive data with a token that has no exploitable value outside its specific context. Example, replacing credit card number with tokens during transactions. So remember, we have studied all these concepts in our previous sessions. Obfuscation include it makes data harder to understand and reverse engineer without altering its functionality. Example include representing an IP address like this one with this. Segmentation, as we have already studied multiple times, it divides data into segments to limit access and exposure to specific groups or system. Example, using VLANs to separate sensitive data traffic from general traffic. And the last method to secure data is the permission restriction, which limits data access to authorized user or system based on roles and privileges. For example, granting read-only access to employees who do not need to edit sensitive data. The last objective of our domain 3, objective 3.4, is the importance of resilience and recovery in security architecture. And the first topic is high availability. So what is high availability? High availability is basically refers to a system's ability to operate continuously with minimal downtime or disruption. It is achieved through redundant components and failover mechanism that ensure seamless operation even in the face of hardware or software failures. So as you all know that the IT system basically are composed of hardware and software components. So the high availability ensures that all these systems work seamlessly, and if there is a component failure either in the hardware or the software, the user services are not disrupted, and this is achieved by employing multiple redundant hardware components. Redundant means that you require two physical server for all the user, but you have, let's suppose, employed 2 plus 2 4. So even if both these servers fail, you still have two servers that can keep the operation running, and similar is the case for the software. And so that's why the term is the high availability, that your services or IT services are intended to be highly available or all times available. Key concepts in the high availability is the redundancy, as we studied that having multiple components of hardware, storage, and network devices to back up each other. Failover, the automatic switching to a backup component if the primary one fails. So as we study, let's suppose you have a cluster of 3 servers and they works as a failover group. It means that if one of them fails, all the services of the user are shifted to the remaining 2. And the minimizing downtime, of course, the main concept or purpose behind the availability is to minimize the unintended or unplanned downtime. The goal is to keep the system operational with a little interruption as possible. So another term in the high availability, so the high availability is achieved through the load balancing and as well as clustering. So what is the difference between these two? First, let's go through the load balancing. So load balancing basically distributes incoming network traffic across multiple servers to prevent overload on a single server. It improves performance, scalability, and resource utilization. And methods includes hardware load balancer, dedicated devices that handle traffic distribution, and software load balancer, software installed on server to distribute traffic. So the concept behind the load balancer is that we have, let's suppose, multiple clients, maybe in dozens or in hundreds, and they want to access certain services, such as, let's suppose, these are, let's suppose, web servers. So the purpose of the load balancer is that there are multiple servers behind this load balancer, and all the incoming client traffic is received by the load balancer, and it is evenly distributed among these servers, so that not a single server is overloaded or overburdened with the client's request. Another purpose of the load balancer is, again, it achieves high availability, such that if one of these server fails, the client traffic is no longer sent to this server, and it is distributed among the remaining available servers. So in this way, it first gives seamless services by distributing the traffic evenly, and again, it also provides high availability, such that if a server fails behind the load balancer, its traffic is distributed among the remaining available server, and the user sees no disruption or downtime of the services. And again, the load balancer may be in the form of hardware, such as this one, or it can be in the form of a VM form factor, or even if the load balancer may be installed on servers as well. So another related term is the clustering, and it is a group of interconnected servers that work together as a single system. So what does this mean? That you have, let's suppose, these three servers, although they are three separate physically server, but they work together as a single group, and they form a cluster. So the basic purpose of this cluster is that the services are served through all these servers, and if one of them fails, the services are shifted to the other two. So it is this uh, concept is also known as fog or failover group. What does this mean? That you have this group of multiple servers, and if one server fails, the services are shifted to other servers, and the user does not see any disruption of the services. Goal is, again, the high availability. If one server fails, other can take over its workload. Scalability, add more server to the cluster, increase capacity. So of course, let's suppose if your users are increased and you want to increase the capacity, you can add another server over here, or even you can make another fog. For example, this is fog 1. If the user are increasing and you want to add another fog, you can add another fog. You can shift the user, 50% user maybe served through this fog, and remaining 50% through this, and so on. You can either increase the number of servers in a fog, or you can increase the number of fogs. And it also, as we studied, provide the fault tolerance, because the system can continue operating if some components, or if some of the member of the fog or the group or the cluster fails. So sites consideration. So the sites here means we are talking about the redundant sites or the recovery sites. For example, you have one main data center. Let's suppose you have your production data center, and you have another DR, disaster recovery data center, somewhere else. So what are different type of sites, so that if there is a disruption or disaster at the primary data center, you can recover your services from these sites. So the sites consideration are crucial for ensuring the resilience and the recovery of security architecture. They involve strategic planning to minimize the impact of potential disruptions, and ensure business continuity. Here is a breakdown of the key sites consideration. So these are the different types of sites. We will now study one by one. The first one is the hard site. So it is a fully operational facility with all necessary hardware, software, and infrastructure to quickly take over operation in case of a disaster. So the key feature of the hard site is that it is the exact replica of the primary site. Let's suppose this is your primary production site, and you have a similar copy including all the hardware, software, infrastructure component at a remote location, so that if there is a disruption, you can seamlessly and very quickly resume services from your this hot site. Key features include that it is fully equipped with redundant system and real-time data replication. So the data over here from the databases is real-time replicated over here. For example, if a user saves something or writes something through the data storage, it is in real time replicated over here as well. So that if a disruption occurs at any time, you have the complete data copy available over here and ready to assume operation within minutes or hours, and ideal for business that cannot afford any downtime. So of course you have all the component over here, so you will incur minimum downtime, but the downside is that it is very costly because you are completely deploying a replica of this original data center having all the components. So another site type is the cold site. So this one is a basic facility with minimal infrastructure, primarily consisting of space, power, and connectivity. So here in the cold site, you have space. For example, you have the facility, physical facility or building. You have power connections over there, and you have the network connectivity over there, or you can say your ISP connectivity. Beside that, you don't have the database backups, you don't have the servers installed over there. So this is the least costly, but it also the side that will require the longest time to recover your services from this side. The key features include it requires significant setup time and become operational. It is suitable for a business that can tolerate some downtime, or it means that they can tolerate a longer downtime, and it is cost effective option compared to the hard side because you are not completely installing all the components in this sites. You only have these three: space, power, and connectivity. So in between the cold side and the hard side, we have the warm side. It is a hybrid approach that combines element of both hot and cold. You can say that it is neither very hot or not nor very cold. It is between them. And features include that it is partially equipped with hardware and software. It means that besides these three, you also have hardware and software components as well. Requires less setup time as compared to cold side, but more than a hard side. Offers a balance between cost and recovery time. So you require less cost as compared to the hard side, but more as compared to the cold, and recovery time is less from the cold side, but more as compared to the hard side. Another side consideration is the geographic dispersion. This means that distributing critical infrastructure and data across different geographical locations. And this is, of course, for the purpose that, let's suppose, if there is a major disaster at your primary site, let's suppose a typhoon or a storm, and it physically destroys the data center. So this natural disaster will not be limited to your data center. It will of course hit the whole city or the near vicinity. So you need another site that is at least hundreds of kilometers away from this site or in another city, so that it is not impacted by the same disaster. So benefits include that it reduces the impact of localized disaster. As I said, it improves resilience against natural disaster and other threats, and ensures business continuity even in the face of widespread disruption. In essence, hard sites provides the fastest recovery but are the most expensive. So this is the summary. Cold sites are the most cost effective but require longest recovery time. Warm sites offer a balance between the cost and recovery time. And geographic dispersion is a strategic approach to enhance overall resilience. So what is the platform diversity? See, it is platform diversity basically involve using different hardware, software, or system configuration across primary and backup sites to increase resilience and reduce risk. This strategy ensures that if one platform experiences a failure, such as a hardware fault, software vulnerability, or configuration issue, the backup system remains unaffected by the same problem. You can say that you have different vendors. Let's suppose you have a firewall from Cisco at the primary site, and let's suppose at the DR or the recovery site you have a firewall from the Juniper. So if there is some vulnerability or some hardware issues with the Cisco devices, you will hope that same vulnerability or hardware issue is not available in your alternate vendor or platform, that is Juniper firewall. The benefits of platform diversity is that it reduces risk of single point of failure. By using multiple platforms, the impact of a vulnerability or attack affecting one platform is minimized. Improved resilience. Diverse platforms provide alternative paths for operations, ensuring business continuity in the face of disruptions. Enhanced security. Different platforms often have unique security features and vulnerabilities, making it harder for attackers to exploit common weaknesses. And flexibility and adaptability means that platform diversity enables organizations to choose the best platform for specific tasks, optimizing performance and efficiency. An example is that a primary site running Linux with the backup on Windows ensure that issues specific to one operating system won't affect both the environments, improving overall system availability and reliability. So what is a multi-cloud system? Multi-cloud system basically involve using services from multiple cloud providers such as AWS, Azure, and Google Cloud. So when you use services of multiple cloud provider, this system is known as multi-cloud to avoid reliance on a single provider for infrastructure and data storage. So the purpose is that it enhances the resilience by distributing workloads and data across different cloud environments. If one cloud provider experiences a failure, other clouds can continue operation, ensuring minimal downtime. Benefits include reduced risk of single vendor lock-in. By distributing workload across multiple providers, organizations avoid being tied to a single vendor's infrastructure or services. Enhanced fault tolerance. So, if one cloud provider experiences issues, workloads can be seamlessly shifted to another, ensuring minimal downtime and business continuity. And optimized cost management. By leveraging the competitive pricing and service offerings of multiple providers, organizations can optimize cost and avoid vendor lock-in pricing. So I hope it is self-explanatory that using multiple cloud provider give you the benefit of a vendor lock-in. It means that you are no longer restricted to a single vendor. You can always shift your services to the second provider that you are using. And it has the fault tolerance, because if there are some issue with your one provider, you can shift your services to your backup provider or the second provider. And the cost optimization means that, let's suppose if AWS is providing a service that is costly, but same services with similar efficiency and lower cost is provided by another cloud provider, you can always use the services of the cost efficient provider. So what is the continuity of operations. So it is the continuity of operation basically refers to the ability of an organization to maintain essential functions and services during and after a disruption or disaster. It means that you want to continue your critical business operation and services when a disaster or disruption occurs. So that your minimum essential services are operational in any case. Purpose is that ensures that critical business operations such as communication, data access, and key processes continue without significant downtime during emergency, for example, natural disaster, cyber attacks, or hardware failure. Important is that continuity of operation is vital for resilience and recovery, ensuring that organizations can quickly recover from disruptions while maintaining essential services to customers, employees, and stakeholders. Example is a company with a continuous of operation plan might have remote work capabilities, backup data centers, and alternate communication systems to continue operations if the main office is rendered inoperable. So what is the capacity planning? So it is capacity planning basically involves forecasting and managing the resources, that is the people, technology, and infrastructure an organization will need to maintain operation, especially during disruption or period of growth. So as we all know that nowadays the holidays are approaching, the Christmas holidays, the 25th December is approaching, and during this time there is a high load on the e-commerce website. So if these e-commerce websites do not foresee these capacity planning and they don't see this upcoming increased need, their systems will be choked and their customer they will face backlash from their customers. So this is the capacity planning and forecasting the growth during special needs or during special occasion. And this capacity planning may include the capacity planning of the people, ensuring the organization has the right number of skilled staff to handle operations and recovery tasks during disruptions. This includes having trained personnel for critical roles and backups for essential functions. Examples include cross-training staff to perform multiple roles in case key personnel are unavailable during a crisis. And the second capacity planning component is the technology, ensuring that the organization's technological systems, hard software, and tools are sufficient to meet the demands of both normal and recovery operations. This includes scaling up technology during high demand or after a disruption. Examples include having scalable cloud storage and computing resources to handle increased load during system recovery. And the third component is the infrastructure, ensuring that physical and virtual infrastructure such as servers, networks, and data centers are adequate for normal operations and recovery scenarios. This involves planning for redundancy, failure, and sufficient capacity to handle peak loads. So, as we were talking about the load during the holiday season. Examples include deploying multiple data centers across different geographic regions to prevent downtime in case one facility is compromised. So now we are talking about different testing technique to test the resilience or your recovery procedures. And the definition is that testing in resilience and recovery involves conducting planned exercises to evaluate how well an organization, systems, processes, and personnel can recover from disruptions or disaster. And now we are talking about different exercises. The first one is the tabletop exercises. So it is a discussion-based testing method where key personnel gather to review and discuss the organization's response to hypothetical disaster scenarios. It helps identify gaps in the recovery plan and improve coordination among teams. Examples include a team discussing how they would respond to a cyber attack on critical system without actually executing the steps. The second test type is the failover. It is testing the automatic switching from a primary system to a backup system in case of failure. This ensures that backup systems are ready to take over operations when the primary system goes down. Examples include testing a database failover from a primary server to a standby server to ensure minimal downtime. Simulation. This is another testing exercise, which is a realistic test of recovery procedures where actual systems and processes are activated to simulate a disaster and recovery situation. This tests how well the organization can perform in a real world scenario. For example, running a full recovery drill including data restoration and system failure to simulate an actual outage. And another testing type is the parallel testing. It is running recovery operations alongside regular business operations to ensure that backup systems and processes work effectively and efficiently without disrupting normal workflows. This helps test the system's capacity to handle both recovery and regular activity simultaneously. So the parallel processing is that your production side is also running, but you also simulate the recovery side and run some services from the recovery side so that your actual services are not disrupted while you also test the recovery side. Example include running a backup data center while keeping the primary side operational to ensure that recovery procedures do not interfere with the day-to-day activities. So now some different types of backups strategies. So backups are critical for ensuring data integrity and availability during system failures, disaster, or data corruption. They involve creating copies of data that can be restored when needed. So the backup can be on-site or off-site. So the on-site backup is storing backups at the same location as the primary system, such as in local servers or storage devices. It's fast but vulnerable to site-specific disasters. So as we already studied that when you store the backup inside your primary data center, you are liable to the natural disaster. For example, an external hard drive connected to the company's main server. Offsite backup is storing backups in a different physical location, often in the cloud or remote data centers to protect against localized disaster. Examples include cloud storage backups stored in geographically dispersed data centers. And what should be the backup frequency? So it refers to how often backups are performed. A higher frequency reduces data loss but can be resource intensive. So resources mean that you will of course require very large amount of storage since you are taking the backup very frequently. An example include daily backups for critical data versus weekly backup for non-essential files. And another consideration is encryption, which is protecting backup data by encrypting it to ensure that it remains secure even if it is lost, stolen, or accessed without authorization. Example include encrypting backup file with AES 256 encryption. And another terminology is the snapshot, which is creating a point in time copy of the data or system state, allowing for quick restoration to a specific moment, often used in virtual environments, such as you can create snapshots of VMs or virtual machines. Example, taking a snapshot of a virtual machine before making major changes to ensure a rollback option. So recovery, the process of restoring data or system from backup to return to normal operation after a failure or disaster. For example, restoring files from a backup after a server crash. Replication, so it is continuously or periodically copying data from the primary system to a backup system to ensure data availability and reduce recovery time. Example, replicating a database across multiple servers for redundancy. What is journaling? It is keeping a log or journal of changes made to data, allowing for recovery of data to its exact state at any point in time. Example is using a journaling file system that tracks changes to ensure consistency during recovery. So, what are some power considerations? So, power solutions are critical to ensuring continuous operation during power outages or fluctuations, preventing downtime and maintaining system integrity. So, power is very essential for the operational of data center. And the power components include, of course, the power from the grid, but as a backup, you also need to have generators. So, provide backup power during long term power failures by converting fuel into electricity. They are essential for maintaining operations when the primary power source is unavailable. So, of course, this is your primary power source, but the generators are your backup power source. So, if this is not available, you will draw power from these generators. Example is a diesel or gas powered generator used to keep data centers operational during an extended power outage. And another component is the UPS or uninterrupted power supply. It is a device that provides immediate short-term power during a power outage or disruption. UPS systems are typically used to bridge the gap until a generator kicks in or to safely shut down system. So when the power suddenly goes out or disrupts, the generator needs time to kickstart. So in this gap, during this meantime, for few minutes, the UPS are used to keep the critical system and servers and machine as well as all the equipment running. So remember, UPS are for the short term, while the generator are for the extended outage. Example include a UPS used in a server room to provide backup power for a few minutes, allowing time to switch to generator power or safely power down equipment. So if you don't have the generator, your equipment will shift to UPS, and meanwhile you will safely shut down the equipment so there is no data corruption or deletion if the power is out or gone for a extended or longer period of time. So that's all for the domain 3. Thank you for watching, and please subscribe, and we'll see you in the next video of the domain 4.